Alright, so what we're going to be doing today is learning about the ideal gas law, how we come up with it. We're going to be then working through Unit 9 Worksheet 2. So what you should have out are your periodic table, some notes, notebook paper, and Unit 9 Worksheet 2. Okay? So the first thing we're going to do is talk about where this ideal gas law comes from. So it starts with the combined gas law, which is P1 V1 over T1 equals P2 V2 over T2. Now something we haven't really added to this, but that you can add, is a fourth term, which is the number of particles, which we usually refer to as moles. So the symbol for the number of particles is N, and so this is N1 is my initial, N2 is my final. And since in every problem we've done so far, the number of particles has stayed the same, we don't even include it. But you can include it like this. So with the combined gas law, it's all about if the conditions are changing. Like, if I change pressure and I change volume, what's the new, temperature going to be? Or, if I keep a couple things constant but change another, what's the new kind of variable going to be? But with the ideal gas law, it's all about comparing what a gas will behave like compared to what we call the ideal gas, which is basically a gas at STP. So the way we derive this is we're going to kind of erase this and just sort of fill in our values for the ideal gas. Now the ideal gas is going to have a pressure that's equal to the standard pressure. So you could say 1 atm or 760 torr or 760 mmHg, but for this we're going to say 1.0 atm as our standard pressure. This volume we'll leave out for a second here, but let's fill in our temperature. So standard temperature is 0 degrees Celsius, but remember Celsius never goes into the combined gas law, so we're going to call this 273 Kelvin. So we need to fill in a volume and a number of particles, and we want it to kind of represent the ideal gas. Now I know I kind of introduced this a while back, but ideally at standard temperature and pressure, all gases occupy the same volume, or I should say 1 mole of all gases. And the conversion here is that 1 mole has a volume of 22.4 liters. I know I borrowed from Mrs. Rinaldi next door a beach ball that kind of represents that. So this is one term that you definitely want to memorize because we'll be working with this. In fact, we're going to do a lab or at least a demo that kind of proves this. So 1 mole of any gas at STP, that's important, has a volume of 22.4 liters. Okay? So what we're going to do with this is we're going to say, well, we need a volume and we need a number of particles. So we're just going to say, here's our volume, 22.4 liters, and here's our number of particles, 1 mole. So 22.4 liters and 1 mole. Okay? And what we do is we're going to basically turn all of this into one constant, which we call R. The letter R in chemistry just means constant, and that's going to basically be a term in our ideal gas law. So if you do the math here, 1 times 22 divided by 273 divided by 1, you're going to get 0.0821 as our number. And the unit, since nothing cancels out, it's going to be sort of a really awkward unit, but you're just going to have to memorize it. The unit for this is going to be liters times atmospheres over moles times Kelvin. This is R. R is the ideal gas constant. Ideal gas constant. So that describes what a mole of gas at standard pressure, standard temperature, behaves like. Okay? So we're going to put all this together, and we're basically going to say P1 V1 over T1 N1 equals R. But in this case, we don't even need the ones because we're not changing anything. So it's PV over Tn equals R. Now this is the ideal gas law, but it's usually not written like this. It's written in a more useful way. So we're going to take this and we're going to rearrange it, and it's going to be, we're going to basically take away the fraction because that is complicated. We're going to bring both these terms up here. So you get PV equals nRT. And this is the ideal gas law. Okay? So this you need to memorize. Ideal gas law. It's a great way to describe the property of a gas without anything to sort of compare it to. Make sure we know what R is. So R equals 0.0821 liters ATM per mole Kelvin. Okay, and make sure you also know the volume of 1 mole of gas. So 1 mole of gas at STP equals 22.4 liters. Okay, so these are the 3 things that you need to take down and memorize for tomorrow. Okay? So let me show you the quick quiz we're going to be having. Again, it's going to be like 2 or 3 minutes, probably. I'm just going to ask you about 5 things. You just tell me the answers. Easy. Okay? You know it or you don't. So first, what is the combined gas law? Now, you don't need to tell me the number of particles. So for this, you're just going to say P1, V1 over T1 equals P2, V2 over T2. Done. What's the ideal gas law? PV equals nRT. Make sure you're conscious of the capitalizations too. Capital, capital, lowercase, capital, capital. Because basically all these terms have different values if they're not capitalized. Okay, 2 out of 2. Done. Next. What is the ideal gas constant, number and unit? R equals 0.081 liters times ATM over moles times Kelvin. And what volume does 1 mole of any gas occupy at STP? 22.4 liters. And finally, what are the conditions of STP? So for temperature, give degrees Celsius and Kelvin. For pressure, give ATM, torr, and mmHg. So STP, so standard pressure is 1 atmosphere, or 760 torr, or 760 millimeters mercury. For standard temperature, it's going to be 273.15 Kelvin, or 0 degrees Celsius. Okay, so these are just things that mostly we should have memorized. Just make sure we have them by tomorrow. Okay, what we're now going to work on is Unit 9, Worksheet 2. So most of this deals with the ideal gas law, which is this one. So I'm going to pick a few random examples. We'll work through them, and then you guys are on your own. You can work together, and this will be due tomorrow. Tomorrow for you guys. All right. So let's skip number 1. We'll do number 2. So a mixture contains 5.00 grams each of O2, N2, CO2, and Ne gas. Calculate the volume of this mixture at STP. All right, so let's see. STP tells us our temperature and our pressure. Let's see. We're going to calculate the volume. So what we need to do is find the moles. So once again, our combined gas, or sorry, ideal gas law, PV equals nRT. So let's see what we know. We know that standard temperature is going to be, let's see, I want to use Kelvin for this because my unit R here has Kelvin in it. So if you say 0 degrees Celsius, it's not going to work. So for temperature, we're going to say 273.15 Kelvin. My R, we know, 0.0821 liters ATM per mole Kelvin. Again, see Kelvin canceling. Volume is what we're solving for. So just call that V again. And pressure, STP, is going to be 1 atmosphere. Okay, so let's solve for volume. Oh, sorry, I forgot moles here. That's what we're going to need to calculate first. So this one's actually a problem involving Dalton's law of partial pressures, because we're going to have 5 grams of each of those 4 gases. So we need to figure out how many total moles we have, and that's going to basically that's going to help us plug that in. So for oxygen, we have 5.00 grams times molar mass of O2, which is 1 mole, over 32.00 grams. Five over 32 equals 0.156 moles. Okay, next, N2. 5.00 grams times 1 mole over, I believe it's going to be 28. Yeah, 14.01. So that'll be 28.02 grams. Gram cancels gram. And that's going to be 0.178 moles. CO2. 5.00 grams times 1 mole over, I believe it's 44.01. Carbon 12.01 plus oxygen times 2, yep. 44.01 grams. Gram cancels gram. 0.114 moles. And the last one is neon gas. 5.00 grams times 1 mole over 20.18 grams. Okay. 5 over 20.18. 0.248 moles. Okay? So just like when we say the partial pressures of all of these add up to the total pressure, it's the same thing with the moles. If I add this many moles to the mixture, you know, we just are going to add all these up and it's going to be the total moles of gas. So 0.156 plus 0.178 plus 0.114 plus 0.248 gives me 0.696 moles total. 0.696. All right. So we have everything we need to solve for volume. So I always advocate rearranging first. Okay? So solving for V, I'm just going to divide by P. So volume equals nRT over P. So let's see, volume is going to equal my moles, 0.696 moles, times my R, 0.0821, not moles. Unit here is going to be liters times atmospheres over moles times Kelvin, times my T, temperature, which is 273.15, divided by my pressure, 1 atm. And here's where we're going to really be careful with our units. Okay, this mole cancels with this mole, because look, numerator, denominator. This liter has nothing to cancel, which is good because we want liters. This atmosphere in the numerator cancels with this atmosphere in the denominator. This Kelvin in the numerator cancels with that Kelvin in the denominator. So our only unit left is liter. Check the units because you're going to get it wrong if you don't. Or if you made a mistake, you will catch your mistake. So 0.696 times 0.0821 times 273.15 divided by 1 equals 15.608 liters. Let's look at sig figs. I give 5.00, so I'm going to go with 3 sig figs. 15.6 liters. That is my volume. Okay, let's look at let's do number 5. Number 5 on the back. Alright, so zinc metal reacts vigorously with chlorine gas to form zinc chloride. Single replacement reaction. Zinc plus chlorine gas, remember that is a Brinkelhoff, forms zinc chloride. That is already balanced, 1 to 1 to 1. What volume of chlorine gas at 25 degrees Celsius and 1.0 atm is required to completely react with 1.3 grams of zinc? Alright, so this question is going to require us to find moles again. So remember, the formula we're going to be using for most of these is PV equals nRT. Pressure is given to us, 1.00 atm. Volume is what we're solving for. N is number of moles which we have to find. R is our constant. And T is given to us. Temperature 25 degrees Celsius, which we're going to have to convert to Kelvin. Okay, so let's see. Converting. Alright, so to get moles of, let's say, what volume of chlorine gas, we need to find the moles of chlorine gas, but we're given grams of zinc. So, the sequence we're going to do, convert grams of zinc to moles of zinc, look for the mole-to-mole ratio, take those moles, plug it in, and get our answer. So, 1.13 grams of zinc times 1 mole over 65.39 grams. Gram cancels gram, and we get 1.13 divided by 65.39 equals 0.0173 moles of zinc. Now, because this is a 1 to 1 to 1 ratio, for every mole of zinc consumed, I am also consuming 1 mole of chlorine gas. So I could just say, this is also 0.0173 moles of Cl2. Okay? I now have everything I need to plug into my formula. So, oops, did not mean to delete that. I believe it was 0.0173. Good, I still have that. Alright, so PV equals nRT. We're solving for V. So volume equals nRT over P. Let's plug in our values. Volume equals, N is the number of moles which we calculated, 0.0173 moles. R is our constant, 0.0821 liters atmospheres over moles times Kelvin. Temperature is given to us, but it's given to us in degrees Celsius. So 25 degrees Celsius plus 273 gives us 298 Kelvin. Pressure is also given to us, 1.00 atm. By the way, if this were given to us in something other than atm, you would have to convert it because our units for R are in liters atm over moles Kelvin. Now you can look up this constant with like hundreds of different units, but in this case we need atmospheres to be our pressure, we need Kelvin to be our temperature. Anyway, let's do the math. 0.0173 times 0.0821 times 298 divided by 1 gives us 0.423. Now let's check our unit here. Mole cancels mole. Liters stays by itself. ATM cancels ATM. Kelvin cancels Kelvin. So this should be liters. And let's see, sig figs. Now I see 3 sig figs, 3 sig figs, and 2 sig figs for the temperature. But remember, with temperatures, the 2 sig figs and 25 turn into 3 sig figs when we have it in Kelvin. So we're going to use 3 sig figs. This is my answer. Okay, so that's number 3 and number 5, or 2 and 5. Okay, so continue working on these problems. Keep in mind the 5 questions on the quick quiz. You need to know: what is the ideal gas constant? What's the volume of 1 mole of any gas? What are the conditions for STP? And I think I may have deleted or worked through one of them. Here we go. Combined gas law and ideal gas law. Okay, I'll answer any questions about this tomorrow. Good luck.